Hey guys, welcome back. Houston Math Prep here. In this video, we're going to take a look at the base 12 or duodecimal system. In base 12, we want to think about things in terms of dozens, like eggs and bakery items. The digits used in the duodecimal system are the normal 0 through 9, but then we need a placeholder for 10 and 11. So we use T for 10 and E for 11. Now I want to point out that some people who do the duodecimal system, instead of using T and E, will use the capital letters A and B. That's just a notational difference and it doesn't change anything. So let's take a look at how we would count in base 12. Well, for the numbers 0 through 9, nothing changes other than we use the subscript 12. When we get to 10, we again use T for 10 and E for 11. When we start to get above 11, we start to count up groups of 12. So we would say, for example, that the number 12 is 1 group of 12 and 0 groups of 1. The number 13 is 1 group of 12 and 1 group of 1. This pattern continues all the way up to 23, I should say, which is 1 group of 12 and 11 groups of 1. Past that, when we get to base 10, the number 24, that would be 2 groups of 12 and 0 groups of 1. Picking up at, let's say, 30. 30 is 24 plus 6, so that is 2 groups of 12 plus 6 groups of 1. We can continue in this way all the way up to EE base 12, which would be 11 groups of 12 plus 11, and then we would go to the next place value and start counting groups of 12 squared, or 144. So let's think about converting, all right? So if we want to convert the number T24 base 12 to base 10, again, we need to think about what each of these place values hold. Well, this one holds powers of 12 to the 0 power, or 1. The next over holds powers of 12 to the 1, or 12. And the next place value over is groups of 12 squared, or 144. So T means that we have 10 groups of 144 plus 2 tells me I have 2 groups of 12 plus 4 tells me I have 4 groups of 1. So I have 1,440 plus 24 plus 4, or I have 1,468 in base 10. Now, to go the other direction, we have a couple of different methods. We could ask ourselves, what is the largest power of 12 that fits into 2,146? But if that seems a little bit challenging for us, we can instead go the route of repeated division by our base, or in this case, 12. So if we do the division 2,146 divided by 12, we get a result of 178 with a remainder of 10. Now remember, in base 12, 10 is the letter T. Again, dividing by 12, we get 178 divided by 12 is 14, again with a remainder of 10. 14 divided by 12 is 1 with a remainder of 2. Since 1 is now smaller than our base of 12, we know we're at our answer, start here, and write going up. So our answer in base 12 would be 1, 2, T, T, base 12. Alright guys, that does it for this video on the base 12 or duodecimal system. To see more like this, keep on watching and we'll catch you in a future video.